Okay, I think we're going. Uh, our next speaker is Miles Sabin. Miles has been working in Scala for longer than most of us. He was one of the founders of Typelevel, and he is possibly best known as the author of the great boilerplate reduction library, Shapeless. Today he's here to tell us about the great new GraphQL library, Grackle. Let's see, Miles, can you raise your hand so I can invite you up onto the stage? Okay, come on up.
Hi everybody, sorry about that. I hadn't actually realized that, or remembered rather, because Justin did tell me, but I'd forgotten that I had to raise my hand before he could invite me onto the stage.
Anyway. We're all still figuring out how this works. Welcome, and I will hand the stage off to you.
Great, well, it's great to be back. I'm just going to try and share my slides, which will hopefully not be too difficult to do. Oops. Let's try that. I think success. Great, okay, well, so today I'm going to be talking about a new GraphQL library called Grackle. So by means of introduction, this is a grackle. It's a bird. It's apparently common in the Americas. It's a rather elegant and sort of fairly kind of feisty looking thing. Apparently it belongs to the same group as blackbirds. I mean, you'll have to ask Rob Norris exactly why he picked that name, because I can't take responsibility for it. But obviously, Grackle, GraphQL, there is a nice sort of resonance between those two, so it seems to fit. I was also kind of digging around on Wikipedia to try and to come up with some sort of some sort of tie-in that might be relevant, and all that I can really find out that seems to fit here is that one of their interesting evolutionary quirks is that they have some funny little thing in their beak, which means that they're very good at cracking hard nuts, which I kind of think is a useful thing to have in a tool if you've got difficult problems to solve. So there you go. So what is Grackle the library? Well, it's a GraphQL server implementation. So what's GraphQL? Well, GraphQL is it's a query language for APIs. It belongs to the same sort of family as things like REST and such like. So Grackle is a GraphQL server implementing GraphQL, and its interesting USP is that it's built from the ground up on the Typelevel stack. So it's built on Cats Effect, FS2, typically built using HTTP4S. May very well be using Doobie or Skunk. Although probably most people haven't heard about this library before, work has been going on it for quite some significant amount of time. I mean, I was looking at when the first commit landed. It's around 4 years ago. So if people have been wondering, well, where have I been in the last 4 years, apart from along with everybody else sheltering from a plague? This is largely what I've been working on. So the work was initially sponsored by Aura Gemini. You'll see who they are in a minute, but anyway, this is Rob Norris's employer, and also a little bit later by ITV. I worked with them for several years, building bits of their new streaming platform, of which Grackle is a fairly significant part. So on that, the ITV, for people who aren't aware of it, is it's a UK broadcaster. It's kind of in the UK you would mention it in the same breath as the BBC. ITV is probably not quite as widely known outside of the UK as the BBC is, but it's a large broadcaster. They're a terrestrial broadcaster, and along with all other terrestrial broadcasters, are faced with having to compete with the new breed of streaming platforms. And so one of the things that they spent some significant amount of time doing is pivoting what had up until then been a sort of a broadcast TV catch-up service into a full-blown streaming video platform. This was something which was done in a very, very, very short period of time, amazingly short period, probably about the space of around a year, which I think is quite a fast time for delivering something like that. Grackle is an intrinsic part of that, in as much as all of the content-related metadata that you would see if you visited itv.com. Outside of the US, you may find, sorry, outside of the UK rather, you will probably find rather limited functionality, but you may get an idea. You'll get an idea of a sort of streaming platform which looks a little bit like Netflix or Disney Plus or something like that. It has lots of tiles and groups of content and things like that. So services built with Grackle are responsible for delivering all of the content-related metadata. So any synopsis text or things like genres and things like that is delivered through that. It's quite again, although ITV is maybe not all that familiar outside of the UK, it's quite a significant platform. It jointly with the BBC broadcast the World Cup last year, more or less simultaneous with its launch. And I had some rather nerve-wracking evenings where we were getting huge spikes in traffic, with up to around 2 million concurrent users on the system, which was interesting, very different experience from working on compilers or generic programming, and lots of fun. So that's a large chunk of what was done with Grackle at ITV. It's also used in ITV's news service. Again, in this case, all the content-related metadata, so synopses, titles, groupings, genres, categories, and that kind of stuff is all delivered through services built using Grackle. At Aura Gemini, so this is Rob Norris's employer. You may be aware that he's been working with this is a university aligned international research group. They're responsible for a pair of telescopes. One is on top of a mountain in Chile, and the other is on top of a mountain in Hawaii. They really do have lasers that shoot into space, and their new observatory management and control system that they're building, the next generation one, is built using Grackle, and it was really the deficiencies of the existing GraphQL implementations available for the Scala at the time. So remembering we're going back about 4 years now, were largely what encouraged Aura Gemini to look for other alternatives, in particular things that would get on nicely with the rest of the Typelevel stack. So we owe them a debt of gratitude for actually wanting to make a start on a project of this sort. So the first question is, I know lots of people know what GraphQL is, but there are lots of people who really don't. So let's have a quick look at an example of what. I have to switch to a different tab here. Let's see if I can do that. I can. Brilliant. So GraphQL is actually, I've gone one slide too fast. Let's go on a bit further. So sorry about that. So GraphQL is an open standard created initially by Facebook, although it's very widely used. As I mentioned before, you could think of it as being something which is somewhat playing a similar role to things like REST in web API design. It differs from REST in as much as it has intrinsic to it the notion of a schema representing services provided, and a notion of types and structure, and these are intrinsic parts of the GraphQL specification, and they, I think, have a number of really quite nice properties. I mean, aside from the fact that requests and responses can have known, predictable, effectively type checkable shapes, I think is enormously important in terms of minimizing the possibilities of errors. There are some interesting features of the design of the language which assist with the evolution of APIs. We can see some of this when I do a demo very shortly. And a key feature is that exactly the content which is fetched on any given query using a GraphQL API is determined by the client. So where you have a situation where you have, say, a service which has many different kinds of clients, maybe performing different, maybe for different platforms, and maybe they perform slightly different functions, they may need different selections of data from an API, which in a traditional REST implementation would be a single large, very broad, monolithic kind of API. Clients are able to basically pick and choose what they need. It slightly complicates the query, but on the other hand, it significantly reduces the amount of overfetching you might expect to do by clients, and then equally in terms of the sort of server-side implementation, overfetching that servers might have to do to sort of backing stores and things like that, because they only need to provide the minimum amount of data required to service a particular query. So let's have a quick demonstration of that to make this a little bit more concrete. So what I'm showing here, this is a web-based GraphQL user interface. It's pointing at a tutorial demo project for Grackle, which if you go and check out the Grackle GitHub repo, you can clone and run this demo very straightforwardly. I've left some instructions in the Talk Grackle channel if people want to play around with this. So for various historical reasons, GraphQL has been illustrated using an example drawn from the Star Wars universe. The schema that the service that we're looking at is implementing, we can see that here. So this is basically, it looks very similar to a set of type definitions that you might see in a Scala program. We have a top-level query type, which defines, if you like, top-level queries that a client might make. In some respects, you could think of each of these top-level queries as being, roughly speaking, the moral equivalent of a REST endpoint of some sort or another. So these queries are parameterized. So you provide them with parameters which are named, they're typed. They are defined to return particular types. In the case of say, for example, the character top-level fields, we're going to provide it with an ID, which is going to be checked, type checked, and we're going to return a result of the character type, where the character type is defined by the interface definition given just below here. So, don't run away. One of the nice things about GraphQL is that by default, it provides a view of the schema that a given service supports, and you would typically expect tools like, for example, this fairly simple web-based GraphQL API to be able to query against that schema and present a reasonably readable and navigable view of the service that's provided. So let's just give this a quick run. So here we're using the top-level character query. We've given an ID. And we're going to ask just for a single attribute of the character, namely the name of the character. So hit run. Well, surprise, surprise. And to illustrate how the feature I described in terms of the client being able to choose what data to fetch, if we look back at the schema, we can see there are other attributes that the character has. So for example, if we wanted to have a look at, say, the friends of that character, we could use the friends field. So let's just illustrate that here. And if you go back to the schema, you can see that the friends returns a list of characters. So we're going to pull out a single attribute of the friends. Let's just pull out the name again. So and then we get a list of the friends of the character. Now the key thing here is that clients obviously determine what attributes they're querying against are relevant to them. So they can choose for a query that needs a minimal subset of attributes available against a given API, clients can request just that minimal subset. And if they need a larger selection of attributes, then they can ask for it as well. And in both of those cases, obviously, we're minimizing the payload that's being delivered, and also, hopefully, at any rate, minimizing the amount of work that's being done on the back end to service that query. Okay, let's just go back to the presentation. So what's going on here? Well, first, we've seen what GraphQL is. Now, what's Grackle? So Grackle is a GraphQL server, so we saw it in action. As I said before, it's powered by CATS effect, FS2, and HTTP4S in this instance, because we're running on an HTTP server. HTTP4S is the natural choice here. It'll support GraphQL queries, as we saw. Mutations and subscriptions are effectively updates and also an ability to provide a stream of results from a query, so sort of kind of a notification, something that can provide a notification or a stream in response to a query's repeated evaluation. And key aspect of Grackle is very much that it has a separation between a view of the GraphQL in terms of its schema, and an abstract model of the backing data. There are various different models that you might take, various different approaches you might take to providing a GraphQL implementation. You could, for example, focus on backing data of some form or another, and then use that to derive a GraphQL interface. Or you could alternatively choose to focus on the GraphQL end and then derive some kind of back end from it. Grackle takes a different model, which is it says, pick your GraphQL schema, pick your data model, and then define in a well-defined and principled and declarative kind of way a relationship between those two things. And this is, I think, relatively novel. It's not something that I think I've seen in quite this form in any other GraphQL server implementation. So as such, because we have an abstract model of the back end, we can support a wide variety of different kinds of back end. Right now, we support in-memory models backed by, say, Scala values, or by blobs of JSON. We also support database-backed models. I mean, when I say database, I mean Postgres, but this is done in an interesting general kind of way that should be nicely extensible to other styles of database and other relational databases other than just Postgres. And it also supports, in general, effectful data sources. I'm probably not going to talk very much about that today. Okay, so other interesting things about Grackle, well, it's structured as a compiler and an interpreter. One of the things you might have noticed looking at the example of GraphQL schema and the query is that it looks quite similar to a collection of type definitions in a programming language, and query looks not at all dissimilar to invoking functions on. Or I suppose in a somewhat object-oriented mode, invoking methods on objects, and Grackle kind of takes this seriously, and views this as being, the problem of serving, GraphQL queries as being a compilation interpretation kind of problem. And as such, the Grackle is structured in that way. So queries are type checked against a GraphQL schema. Queries are then compiled into an internal query algebra. So the query algebra is something which is effectively defined with respect to the abstract data model that I referred to earlier. So in other words, something which is completely neutral as to whether we're dealing with in-memory models or database-backed things or whatever. We're really thinking of the kind of programs as values kind of model that I think we're reasonably familiar with in the functional programming world. One of the nice things about programs as values is that as values they are manipulable, they can be transformed, and various interesting things can be done with them. One of the interesting things that can be done with them is that they can be transformed and compiled to other forms. So, for example, as well as compiling a GraphQL query into the internal algebra, which is going to produce the blob of JSON as a result of the query, we can also compile it in a backend specific way to actually materialize the data that we're going to need to construct that result. And the main headline here is that we can compile it to efficient SQL, which allows us to execute an efficient query against the Postgres database, typically using Doobie or Skunk, and use that to construct the results. Most of this is done completely transparently to the developer of the application. Okay, so we have to think a little bit about how queries are connected, linked to the backend data. I've mentioned already that we have a compiled form of the query. It's our query algebra term. We also have, and you're going to see in a slide or two exactly what this pans out as. The GraphQL specification is very, very, I won't say vague. It's not. It's very precise. It's actually a very, very clear and readable specification. But there are lots of things which are not baked into the specification. So there are lots of bits of natural query-like functionality that you might expect to have some sort of, if, for example, in the I'll flip ahead actually. In the example I gave in the demonstration, you can see that there is an argument to the character field here, which is essentially specifying some kind of a filter operation or some kind of argument to a filter operation. There's no specification there's nothing within the GraphQL specification which defines any semantics for fields of this sort. So we have to provide some semantics. The application of GraphQL has to define some application-specific semantics for that. Grackle makes this a first-class thing by specifying that we have an elaboration phase, a sort of a compiler phase, if you like, which takes the compiled query algebra term that we've had directly from interpreting the query and sort of enhances it with things which represent the application-specific semantics. We also need to specify a linkage to the actual data that we're using to service the query. So that is going to be a backend specific mapping, and it's declarative in form. Once we have actually obtained or located or identified the data we need to satisfy the query, we need some mechanism for traversing through that data, and that's specified in terms of a backend specific cursor which indexes into the data and allows us to construct the resulting JSON value. Okay, so let's unpack some of that a little bit. Here's a little fragment of the GraphQL schema we saw in the demo. We have a query type, and we have which specifies the top level character field, and we have a character interface type which specifies a name attribute. So this is the schema. This is the query, which makes use of those terms. This query is going to be compiled into a value constructed from this query algebra. So this is a fixed, stable query algebra, which for the most part is not needed. It's not something that you would need to work with in any great detail beyond what you're going to see on the next slide. But this is, if you like, the kernel of Grackle, the kernel of the execution model for executing GraphQL queries. So our query, which if you remember looked like this, is initially compiled into something which looks like this. We're selecting a character. The none that you can see here is an alias, which you don't have one of in this particular instance. Here we have a currently untyped representation of the arguments, and then here we have the child, the child selector. In other words, the name underneath the selected character. We need to do a little bit of, so this is the kind of thing that the client needs to provide. So this is basically this is code which is executed as part of the elaboration phase I mentioned earlier on, where we need to identify that we have a character field which has a binding, and what we do is provide that with semantics by saying that using the query algebra that we saw a couple of slides earlier, we're going to specify that providing that argument defines a filter operation over the data that's back in the model, and also asserting that the resulting value of that filter is a single value rather than multiple values. The result of that is this elaborated query. At this point has now been fully type checked, validated against the schema, elaborated. This is now something which is directly executable against the in-memory model that we've been working with. The in-memory model is actually a Scala value. It's simply a list of characters in this particular case. This is a fairly simple-minded implementation. So this is a character here is a Scala data type. The set of all characters is a list of this data type. We define a mapping for the query type, which specifies that the character field corresponds to this full set of characters, the Scala value, and we make use of sort of generic programming techniques in this case to allow the filter and the unique operators from the query algebra, which we saw here. So unique and filter here, and the equality operator to identify the relevant value to pull out. That's pulled out. We have a cursor into the resulting character data, which can then be used to populate the JSON value. Okay, that's a very, very rapid run through, and I'm aware of the fact that I'm rapidly running out of time. So database-backed models are, I think, probably one of Grackle's most significant features. It's not unknown elsewhere, but certainly in the form that it appears in Grackle, it's certainly novel in the Scala ecosystem. In this case, I would have shown you another demo at this point, but unfortunately I'm out of time for that, so I'm going to whiz through this fairly quickly. We're looking here at a more complex schema, which is in this instance going to be representing countries and cities belonging to countries, various bits of geographical data. So this is a fragment of that schema. So we can query a country by its code. A country will have a number of cities. Cities will have a name and a population. So this is the GraphQL schema. This is a query that would query against that schema and against the data set. The query in this case is going to be processed in more or less the same kind of way elaborated more or less the same kind of way that the one we saw before was. Here we have more nesting. Most of this is handled by the implementation, but the main thing is that the application has to provide semantics for the field argument here, and to provide it with an interpretation that corresponds to a filter based on equality on the country code, and then a uniqueness assertion at the top to say that there is just one. Now, for a database model, which is what this is going to be backed by, we would need to have some database tables. These are the corresponding fragments of the database table in this particular instance. You can see we have a table of countries which have a code, a name, and cities which have an ID, a name, and the corresponding country code. So you can probably imagine that at this point we're going to have to be thinking in terms of performing joins of some sort. And that is indeed what will be the case. So moving ahead, we would provide Grackle. So this is something the application developer would need to provide is a representation of this database schema in a form which Grackle can make use of. Here we're working with Doobie as a backend, and you can tell that from the fact that we're making use of Doobie codex here to interpret the database columns. So in this case, we have a more interesting mapping than the last time. Rather than just relying on generic programming to do magic and do everything for us, we need to explicitly specify a mapping between fields in the GraphQL schema and fields in the database schema. So to a certain extent, there's some redundancy here because the names are similar. But I'm sure as you can imagine that in real world examples, you would probably expect there to be considerable divergence between the kinds of naming or some aspects of the structuring that you would want to have in your GraphQL schema and the structure of your database. So the fact that we have an independent mapping relation specified by the mappings here is something which is actually, although in simple cases it may look somewhat more verbose than you might expect, in general it actually turns out that it's enormously valuable. You can also hear that we're specifying to reach the city's values from a country value, we need to specify a join, and here we're specifying the join in terms of join on the database table. So these are the columns from the database tables here. And this is enough for the SQL compiler in Grackle to be able to work out that this is the SQL needed to satisfy that query. Now, this is pretty much the SQL that you would write by hand. And to some extent, you might look at that and say, well, why wouldn't I write that by hand? Because it's really not very complicated. The issue here, and the thing which makes life very, very difficult when you're trying to back a GraphQL API with a database, at least with a relational database at any rate, is that obviously one of the key features of GraphQL is that the client chooses the query that it's going to make. So whether or not you actually needed that join there at all in the first place is dependent on whether or not the client has actually asked for any attributes of the of cities under countries. Equally, you might traverse further through the graph. That might generate further joins, or you might traverse different parts of the graph, and maybe you need different parallel joins of one source or another. Working out exactly how to construct efficient SQL corresponding to an arbitrary query is a very, very difficult problem, and that is something which a lot of work has been put into Grackle to try and address. Okay, And this will give us a result like this. Sorry, I have massively overrun my time allocation, which means that I couldn't show you the demo, but the demo would have shown you that as a result, so you're not really missing that much. As I said also, that you can try the demo out yourself, and you can see this in action on your own machines, not just online. So project status. Well, there's lots of things I haven't had time to talk about, including like half my talk probably, but other things that you'll hear people talking about are, for example, making, sort of incorporating the results of, say, a call on a REST API or a call on another GraphQL API or some other kind of source which requires some kind of an effect and some kind of mapping into a GraphQL structure. This is something we support. Obviously, a graph API, it has a graph-like structure. You can insert effects more or less anywhere within that structure. One thing you may very well come across when talking about things like this is something called the N+1 problem, which is that you might find yourself making a top-level query which results in a cascade of queries to some other service. I mean, it often appears in context with databases where things are not arranged in quite the way they are in Grackle, where you might end up making a very large number of independent database queries to service a single response. This can also happen with queries against REST, say external REST APIs or things like that. Well, Grackle has a mechanism for batching and collecting those kinds of nested effects in a way which minimizes the number of subsequent activities that have to happen to satisfy the query. The other thing you might hear about is things like federation, composition. There is evolving support for that within Grackle. Again, I haven't had time to talk about it some other time. I'll briefly mention that Grackle does have full support for custom things called directives, which are very similar they would look just like Scala annotations to you. There is a sort of convention of using these things to specify sort of authentication, authorization attributes. So, for example, you might annotate a field as something that requires a user to be authenticated and have a particular role. Otherwise, they're not allowed to. Either the query as a whole is rejected, or the value is returned as a null or something like that. The query algebra model, the sort of the program as a value kind of approach, actually makes implementing these kinds of things extremely straightforward, and we have examples of that in the Grackle code base. Other things which, again, you might think you might almost expect to be sort of baked into the GraphQL specification, but aren't, are actually only handled in sort of vendor-specific, in sort of implementation-specific ways. Are things like paging. If you've got large data sets, you might want to page through those. And you might want to do things like, for example, you might have you have sort of nested fields, each with attributes, each of which provides filters or modifies behavior in one way or another. You might think in terms of those like CSS, for example. You might want attributes from outer fields, arguments to sort of propagate to inner ones. Again, the program as a value model with structured recursion is actually a very, very nice fit for this, and we can do that very nicely. And again, that's using lots and lots of CATS infrastructure to make that kind of stuff relatively straightforward. Okay, I'm just going to wrap up now. Apache 2 license is now a full Typelevel project. It's just landed in Typelevel in the last couple of weeks. You can find it at typelevel/Grackle on GitHub. It's available for Scala 2 and 3, Scala.js, Scala native, which is wonderful. Thanks to Armin for lots of work on that. Current version is 0.15.0. Version 1 will be imminent. I was hoping to get it actually out for today, but didn't quite get there. As I mentioned when I introduced it, its use at ITV, it's new. You probably haven't heard of it before, but it is battle tested. So it's been used on very easy in use on very visible high traffic sites. It's something you can, I think, rely on. There's a demo, a tutorial. You've got links to that in the Grackle channel. Lots and lots of scope for contributions. There are lots of things which are quite low level, which means there's lots of scope for building higher level abstractions on top of it. And that's something I would very much encourage people to try. It's a compiler. Compilers are fun. We need lots more backends at the moment. We've really got sort of in-memory stuff, and we've got Postgres. I mean, Postgres obviously is wonderful, but there are other things out there, and it would be nice to support them too. And that's it. If we have any time for questions, then let's have some questions. Otherwise, come and talk to me in the chat, and I will stop sharing my screen.
Thank you much. That is fabulous. Having built GraphQL servers a couple of times on other libraries, this looks fabulous.
Please do play around with that. Also, I'm super sorry that I just completely got the time wrong. I mean, I always used to do that, and I'd improved, but then in the sort of all the years of no conferences, I think I've lost the knack of getting the timing right. So apologies.
Quite all right. Lots of good content here. I do think we should take questions and answers over to the Talk Grackle channel over on Discord. Thank you very much.
Cool.